Okay, homework questions. So remember, when we're approaching a question like this, always just highlight the information that you know. So what we're told is the diameter of this circle is 28 centimeters. So I can immediately write down that the radius is going to be equal to half of that, which is 14 centimeters. Okay, and what other bits of information did they give us? The area of the circle, the area of the metal remaining is equal to 146 pi centimeters squared. And we need to find the radius of the semicircular piece cut out. Okay, so first of all, I'll find the area of the total circle, and I should be able to find that using pi or squared. And if I do that, I get pi by 14 to be squared. So this is the area of the whole circle, so the full circle. And when I do that, I get 196. Just write in terms of pi for now, they didn't tell us anything else. And you can see that the area of the metal remaining is in terms of pi. So 196 cm squared. Okay, perfect. We're going to use that solid boxer for the moment. Now, I'm told that the area of the metal remaining is 146 pi cm squared. So I'm going to find the area of the semicircle by taking 196 pi minus the 146 pi. And that's going to give me 50 pi cm squared. So that's the area of the semicircle. Now, if I think about the area of the semicircle, that's just going to be half of this formula that we use here. So what I can do is I can say half pi or squared is equal to 50 pi. Okay, so that's the area of the semicircle. We don't know the radius, so I can't do anything with that at the minute. What I can do here is I can cancel both pi's. So I'm left with a half r squared equals to 50. I can then divide both sides by a half, or if I flip that, I'm going to get r squared is equal to 100. So that's just dividing both sides by a half to cancel out the half in front of the r squared. And as we know then, r is equal to 10 if r squared is equal to 100. So that's going to be the radius. Remember to put in your units of measurement, so radius is equal to 10 centimeters. I also just want some of you to get into the habit of highlighting your answer. I found in your exams that it was very messy. Some of you, it was very hard to find where your answer was or what your final answer was. Okay, so the next question, the diagonal D of the cube shown is 5√7 centimeters. Find the volume of this cube to the nearest centimeter. So first of all, if it's a cube, we'll know that all sides are equal. So if I'm thinking about the volume of any rectangular shape, we'd say that the volume is equal to length multiplied by width multiplied by height. So in this case, our length, width and height are going to be the same. So we'll just have a quick look. First of all, they didn't tell us anything about length, width and height, but one thing that they did tell us was they told us that D is equal to 5√7 centimeters. Now, if we look at what D is, we can actually see D creates a right angle triangle. So if I draw out that right angle triangle, or even if I just show you on the diagram itself, okay, so this is my D. Then the bottom, if we just look at the side here, we could call that X. And the bottom, we don't know either. So what we need to look at, first of all, let's just take a side of that triangle. So we've already said, or of that cuboid. So we've already said that that is X, and this here would also be X. So if we're trying to find the hypotenuse, if we take that a right angle triangle here, we've one side is X. All of those sides, as we know, are all of the same length, okay? But if we wanted to find that the hypotenuse, well then what I'd say is x squared plus x squared is equal to d squared. let's, to avoid confusion, let's call it y squared. Okay. So what I'm going to get then is I have 2x squared is equal to y squared. And if I want to find out what y is equal to, which we're just letting on that y is going to be this hypotenuse. So I'm going to root both sides. And what I get is root 2x is equal to y. Okay, so now we have a value for a diagonal. And why do I need that diagonal? Well, if you look at my shape down the bottom, so this here, I'm looking for this bottom part of that shape. So if you can imagine that this relates to the cross part, and then we have that bottom square as well. Okay. Okay, so what does my shape look like now? Well, that diagram we had, so we know that d is equal to 5 root 7. We know that one side we'll call x, and we know that the bottom is going to be 2 root 2x, because that's basically our hypotenuse of a side if we were to look at a side. Why am I finding all this out? Because I want the value of x. So let's go ahead then. We have x squared plus root 2x all to be squared, and that's going to give me 5 root 7 squared. Again, this is just Pythagoras theorem, so that's all I'm following. X squared plus, now root 2 to be squared is 2, and x squared is just 2x squared, is equal to, so what we have here is 5 squared is 25, multiplied by 7, which is going to give me 175. Please put that into your calculator, do not do it in your head. So I get 3x squared equals 175. X squared is equal to 58, and okay, so that's coming up as a decimal, so that's going to be 58 and a third. And then I am just going to find out what x is. So x is equal to 7.6 376. So I'm going to leave it as I'm going to leave it as a 4 decimal place just for accuracy, and then if I want to round it towards the end I can round it if it just gets too big. So we had to find the volume, so all I'm going to do then is the volume. In this case we said was length by width by height. Because the length and width and height are all going to be the same, it's going to be 7.6376 multiplied by 7.6376 multiplied by 7.6376, or we can say that that's cubed. And then as a result we get 445.5282. I'm just going to round that to 53 centimeters cubed. Remember, centimeters cubed for volume. And I'm just going to box that as well, just so that we have a clear answer. Okay, for the next question, so the sides of a square are each of length 2r as shown. Circles are drawn inside and outside square is shown. Find the radius of each circle in terms of r. Okay, so sometimes I think it's handy if you just draw what the radius is, so out to there. And what I can see, so if you imagine that center point, I know it's a little bit rough, but if you imagine that's the center point, well, what I can see in that inside circle, well, the length, like the diameter of that inside circle is equal to 2r, so then the radius is just equal to r, because if it's 2r, just divide it by 2 as we know to get the radius. So that one's not an issue. What I need to look at now is that if I want the radius of the outside circle, I will need to get from here out to here. Okay, so if I go from there out to there, then what I see is if I went across here, that would give me the diameter, and I can actually use my square, because I could use Pythagoras theorem to find out what the diameter is, in this case the hypotenuse. So I have 2r, so I'm just trying to find the 2r squared. Remember, put that in brackets like so, plus 2r squared, and that's going to give me that diameter. Let's call it just capital D. Okay, so it's going to give me this guy, the capital D. So what I have then is 2r squared, so that's going to be 4r squared plus 4r squared is equal to D. So we're going to get 8r squared is equal to D. Okay, so now I root both sides to get r by itself. Now what I would say to you is not so much to get r by itself, to get r as something to the power of 1. We're not going to worry too much about the right hand side, but I will put it there anyway. So the square root of 8, that's going to give me 2 root 2 r, and that's going to be equal to the square root of the diameter. So our diameter is such, that's our diameter, the value of our diameter. So what we see then is that if our diameter is equal to 2 root 2 r, then our radius is going to be half of that. So if I divide that by 2, it's just going to be root 2r. Okay, so for the last one then, it says verify that the areas of the two circles are in the ratio 2:1. Okay, so if we say pink versus green. So the area of the pink circle, we know that the area of a circle is pi r squared. Now we found that the pink circle is just this one here. So r is equal to r, so that's just going to be r squared. And then on the green side, we know that that's going to be pi, and that's going to be root 2 r to be squared. Now, if we go ahead and simplify that then a little bit further, what we'll get is we'll pop those two off there. We get r squared is equal to 2r squared, which we can see that's the same as 1. R squared is in the ratio of to 2r squared, so that's 1 is to 2, so that's correct. Okay, so for the question on the trapezoidal rule, so first of all, just to give a quick recap here, when we look at this formula, which is on page 12 of our log tables, y1 refers to the first height. H refers to this distance here. So just to show you this guy here, okay, so on this one it'd be 10 and on this one it'd be 20. So it's along the axis, if we can imagine that that's an axis. And then your yn refers to the last height, and n minus 1 is the second last height. So y n minus 1, second last. Okay, so the area for the first one, so what we're going to get using our formula, we get A approximately equals to H, which is 20 over 2. And then you have y1, which we can see here if we look at this, there is no height. So there's no height here, so that's going to be 0. And then we have, when you look at our last height, we see 4 plus 6, so that's going to be 10. And then we have plus 2, so just following the formula now, it's going to make that a little bit smaller, move it over a little bit. Okay, so we have y2, so y2 is 40 plus 10, which gives me 50. y3 is 45 plus 10, which gives me 55. Just going to make that smaller again. So we have, so that's a 45 plus 10, 55. 50 plus 20 is 70. 52 plus 20 is 72, and 20 plus 10. So I'm just going to write all them out. So we have 70 plus 72 plus 30, and we close our bracket. And when I stick all of that into a calculator, just give me a second now. Okay, so I get an answer of 5640 meters squared for that one. Now for the second one, we actually have no first or last height for this second one. So we can say that the area is approximately equal to, okay, our h is 10 over 2. Our first height is 0, our last height is also 0, plus 2 by, in this case we don't have to add anything here, so we just have 22 plus 28 plus 30 plus 28 plus 22, and again popping all of that into my calculator. I'm going to get 1,300 meters, meters squared. Yeah, in meters squared. Okay, so next question. A machine part consists of a hemisphere and a cone cut from a single cylindrical piece of metal as shown. The cylindrical piece of metal has a radius of 12 centimeters. Okay, so if we look at just drawing that, you know me, I like to draw my diagrams. If we're talking about the cylinder itself, which these shapes are in, the radius of that cylinder, they're telling us, is 12 centimeters. And then the height of that is also 18. Now, if I look here at my sphere, the radius here is also going to be the same as that there. So just that's worth keeping in mind. Find in terms of pi the volume of this machine part. So what we're trying to find here is the volume of the sphere and the volume of the cone, and that's all we want. The only information that we have is information about the cylinder. So what we need to think about now is we need to think about what information we can use. So just drawing out a little separate diagram there, we know that this is the radius and this is also the radius. So the radius, if we want to use that information to figure out about the sphere, we can. And then similarly, if we look at the cone, we know the radius of the cone, and what we normally need to know as well is the height, so that then we can figure out what the slant height is as well if we need to figure it out. Okay, so if I look at that, then I can see that this guy here and this guy here make up the total height of 18. So I can see then that my height of the cone, so even if we just decide maybe best thing to do here is to break it down into each section. So if we first of all look at the cone, so my height of the cone is going to be equal to 18 minus the radius of the sphere, which is going to be 12. And that's going to give me a height of 6. So now we can use the volume of the cone formula. So that's a third pi. We're going to use r squared. So our r is 12. And then h we know now is 6. And that's going to give me a volume of 288. I'm just going to write it in terms of pi because that's what the question says. Pi, and our measurement is centimeters, so that's going to be centimeters cubed. Perfect. So now we're going to find the hemisphere, and the hemisphere then is going to be, so in the log tables we can see that the volume of a sphere is 4/3 pi r cubed. So when we want to find out the volume of a hemisphere, then that's going to be equal to half of 4/3 pi r cubed, or we can say that that is going to be 2/3 pi r cubed, and that formula is not in the log tables, just be aware of it. Okay, so then from that we already know what r is, so my volume is going to be 2/3 pi by 12 to be cubed, and when I shove all that into my calculator, I'm going to get 1,152 pi cm cubed. Okay, last part then is that I need to look at my cylinder. So let's just bring that guy down here. So my cylinder then is the volume of a cylinder, which is pi r squared h, again from your log tables, and that's going to be pi, my r is 12 squared and my h is 18. Okay, So using or popping that into the calculator, then I'm going to get 2592 pi, and that's cm cubed. Fabulous. So all I need to do now in order to figure out what the volume of the actual part is I need to take away the bits that I don't need. And actually, when I looked at this question, I thought that the cone and the sphere itself was the part. And then I thought that you would just add these two together and that's it. But I can see that when you look at the workings, they're actually saying that this part is hollow, this part is hollow, and the part is the cylindry part. So I think that would be made more clear in an exam question. So what we're going to do then is 2592 pi minus my 1152 pi. So essentially what we're trying to find here is the empty spaces that you can see here and here. And then minus 288, and that's going to pi as well. And that's going to give me 1152 pi cm cubed. Okay, next question. Water flows through a cylindrical pipe at a rate of 10 centimetres per second. The diameter of the pipe is 7 centimetres. The water was poured into an empty rectangular tank of length 55 centimetres and width 20 centimetres. Okay, what is the depth of the water in the tank after 1 minute? Okay, first of all, we need to figure out what is the volume of the cylindrical pipe. So that's this pipe here. Obviously, I'm just drawing it vertically, not horizontally. And we know that the diameter is 7 centimetres. So that tells me that the radius is going to be 3.5. And the fact that it says at a rate of 10 centimetres per second, that means that the height of that pipe is 10 centimetres. So we have the height is equal to 10. And then if we get the volume, we get pi, r is 3.5 to be squared by 10, which is the height, and I pop that into my calculator and I'm going to get 384.65 centimeters cubed. So that's my volume of the pipe. And then it says, what is the depth of the water in the tank after 1 minute? If approximate pi. Oh, sorry, actually, before I did that, instead of pi, I should have put in there your 3.14. So the depth of the water in the tank after 1 minute. So first of all, let's figure out how much water goes into the tank after 1 minute. So if we know that that's 384.65 centimeters cubed goes in per second, then we just need to multiply that by 60 to figure out what it is per minute, and I'm going to get 23,079 centimeters cubed. So that's in 1 minute. Now, if we look at the volume of the tank is going to be equal to length multiplied by width multiplied by height. Now we know that that volume should be equal to 23,079, because what we're going to be trying to find here is the depth of the water, which we know the depth of the water is going to be the height. So just make that a bit smaller, and then what we have is our length, well, we know is 55, just a little bit of algebra here. Our width is 20, we want to find the height, and then we know that that'll be all equal to 23,079. So when we simplify that, obviously multiplying those two numbers and then dividing both sides by the number we get, we are going to get a height of 20.998, and then that's going to give us, we're going to approximate that to the near centimetre, so that's 21 centimetres. Okay, for the last one, I just went ahead and did it because it's very similar to what we were looking at. The only difference in this is that you need to make sure that you convert So 0.6 meters is 60 centimeters and 0.9 is 90 centimeters. You're going to find the volume of the cone. First of all, find the volume of the cylinder, so how quick it passes through. You'll get 135 pi centimeters cubed, and that's per second. That's how much water flows in. Volume of the cone then, just obviously with our converted radius and converted height, pop that in, and we get 108,000 pi centimeters cubed. It doesn't say anything about what you are going to put pi as, so just leave it as pi. As I've mentioned before, pi is the most accurate form. Then just quick recap here on distance, speed and time, if you remember that from junior cert. So if I want to find time, I put my finger over time and I get distance over speed. Distance is obviously the same as, in this case, would be the equivalent of the volume of the cone, so how much it has to fill, and that's 108,000 pi, and then the speed is 135 pi. Really important that when we're doing distance, speed and time, or volume and speed, that we are not looking at meters per second. We're looking at centimeters per second, meters per minute, or meters per or kilometers per hour.